Hello, this is Dr. Moore, and this is my video on eutrophication. Eutrophication begins with nutrient pollution, and then that nutrient pollution kicks off a chain of events that ends up in having low levels of dissolved oxygen in a body of water. We call this condition hypoxia, and hypoxia is bad because organisms need oxygen in order to perform cellular respiration. And if dissolved oxygen levels get too low, fish don't have the oxygen they need for cellular respiration, and so they die. So in this video, I'm going to connect the dots. I'm going to explain how nutrients in water can lead to low oxygen levels. Let's start by talking about where these nutrients come from. Nutrients can come from fertilizers that farmers apply to their crops. It can come from manure from animal agriculture operations. It can come from human sewage, and it can come from detergents because detergents contain phosphorus, which is a nutrient that plants need. When these nutrients make their way into a body of water, they fertilize the algae population so that the algae population grows in size. They're like, yay, so much food. Oh my gosh, let's feast. Let's make babies. Let's make more babies. And as a result, we get this thick layer of algae at the top of the body of water. And what that does is it prevents sunlight from penetrating to the bottom where we have this submerged aquatic vegetation. And so the submerged aquatic vegetation starts to die. We don't have any sunlight. We have no food. We're starving. We're dead. This is going to be one of the ways that eutrophication leads to low oxygen levels because these dead plants are not performing photosynthesis, and so we've lost a source of oxygen to the body of water. But the real cause of the depletion of oxygen happens next. So some of the algae are going to sink and die just because algae don't live terribly long, and so they've lived their entire life cycle. Oh, we had a good life, but we're dead now, we're dead. And this dead algae starts to feed decomposers who are like, nom, 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 eating all of the dead plants and dead algae. And when decomposers decompose, what they're doing is performing cellular respiration, which means they need oxygen. The decomposers are using all of the available oxygen in the water, leaving no oxygen available for the rest of the organisms that live there. We're dead. We're going to run through that one more time in case my cartoons and voices didn't make sense to you if you're looking for something to put in your notes. Eutrophication begins when nutrients stimulate an increase in an algae population. Those algae then block the light, preventing submerged aquatic plants from performing photosynthesis. This will decrease oxygen levels because oxygen is a product of photosynthesis. Step 3, the algae die, and that's going to start feeding the decomposers. And the decomposers will consume the algae using dissolved oxygen in the process. So they're performing cellular respiration to break down the algae. That's going to use up the dissolved oxygen in the water. And that means the oxygen levels drop and fish die. We represent the process of eutrophication using a graph called an oxygen sag curve. On an oxygen sag curve, we have distance downstream on the x-axis. So this is upstream and water is flowing this way. And then we have on the y-axis, the relative concentration or demand of two different quantities. The first one is dissolved oxygen, which is represented here by a solid line. And dissolved oxygen is just what it sounds like. It's the amount of oxygen that is dissolved in the water. Our second quantity is the biological oxygen demand. This one's a little bit trickier. What this represents is how much oxygen is required by decomposers in order to break down the available organic matter. And so that's represented by this dashed line. And what you can see is that right about here at point B, we see that biological oxygen demand is shooting up. Meanwhile, the amount of dissolved oxygen is crashing. That suggests to me that a bunch of nutrients, probably in the form of raw sewage, were added at about this place. And the decomposers have demanded a lot of oxygen to break down that sewage. That's why demand skyrockets. And because there's so much demand from the decomposers, the amount of dissolved oxygen is decreasing. The last thing that I want to mention in this video, because I imagine now you are hiking through the woods, pointing out to your hiking companions every eutrophic body of water you can find. Oh, look at this eutrophic lake, look at this eutrophic pond. But you might come across a body of water that's not eutrophic. And I haven't told you what the word for that is. Here you go. Oligotrophic. Oligotrophic refers to a body of water that has very little nutrients in it, which means that the water is clear, the sunlight penetrates straight to the bottom, so you can see the gorgeous rocky bottom of that lake. These are the qualities that define an oligotrophic lake. And that concludes my video on eutrophication.